Hello, we're going to go through step by step how to calculate percent error. We're going to use the step by step as they're described on the warm up about percent error, but we're going to use a different problem as a model. So we need to start with an accepted density, an accepted value, and a measured value. So we're going to look at this data right here for group 1 that was measuring a bur oak. So the accepted value, the actual age was 96 years, but their estimated or measured age was 87 years. So I'm going to come to my workspace, not that. I'm going to come to my workspace and say it was measured at 87 years, but the actual, we're going to go back and check our data here, actual age was 96 years. Okay, so that's the information that I have about this tree. I'm being careful to label all of my numbers because we never want naked numbers running around. Let's look back at our step-by-step how we're going to do this. So step 1, it says, is to subtract the measured minus accepted. So let me go to my workspace. And we want measured minus accepted. So in this case, that would be 87 years minus 96 years. Where is my screen? So it's okay if you need a calculator for this, but I got -9 years. What this is really telling us is how close was our measurement to the actual. And so it doesn't really matter that it was 9 years under. We're going to get rid of any negative signs. In math, we would call this taking the absolute value and just settle on 9 years because that's how close we were. We were 9 years away from the actual. So first we did the measured density minus the accepted density, and then we made it a positive number by ignoring the negative sign. So step 3 is to divide the number we just got divided by accepted. So we're going to take 9 years divided by 96 years. So the order of this division matters, and I've got a small number on top and a big number on the bottom. So I should be ending up with a very small number, definitely less than 1, because 9 is much smaller than 96. So I put that into my calculator, and I got 0.09375. And years divided by years, this one now doesn't have a label. This is a decimal, and I want to turn this into a percent for a percent error. So per cent means times, cent is 100, like there's 100 cents in a dollar. So if I take 0.09375 times 100, that means I bunny hop my decimal 2 places. That gives me a 9.375% error. So remember, percent error is how wrong you were. So you want a low percent error because you want to be only a little bit wrong. The lower percent error means that you are closer to the right answer. This is a lot of decimal places to have here. So I want to round to the tenths place. The tenths place is right here. So I look right next door. If the number is 5 or more, I up the score. So I'm going to round that to 9.4% error. You can replay this and pause for as much as you need, and I hope that this helps you with your future problems.